Good morning, Algebra 2 students. Today we're going to continue our TSI, SAT, ACT review. We're going to look at exponent rules. That may have been a while since you've seen these, so we're going to do a little review and a practice. So this is pages a little summary we'll go over of the exponent rules. So do you remember when you have a to the m times a to the n, the rule is for that you're going to add the exponents. When the bases are the same, remember this is the base, this is the exponent, okay? When you have the same base, you're going to add the exponent. So if we have 3 to the 4th times 3 to the 5th, I just rewrote the same thing. So what we're going to do here is we're going to add the exponent. So we have 3 to the power of 4 plus 5, which makes 3 to the 9th. X to the 7th times x to the 9th. We're going to add the 7 and the 9. You get x to the 16th. And then b to the a times b to the c, we're going to add and get b to the power of a plus c. So this says to multiply terms that have the same base, you can add the exponents. Okay. Then the next thing, what are we doing? Instead of multiplying, in the next one, we're dividing. When you divide, you subtract the exponents. So I would have a to the m minus n. So this one, 4 to the 7th divided by 4 squared. Subtract your exponents. 7 minus 2, 5. For this one, x to the 17th over x to the 21st. 17 minus 21 will be x to the negative 4th, and we'll see how to take care of that negative exponent here down here at the bottom. So to divide terms that have the same base, you can subtract exponents. Okay. The next rule is power to a power. When you take one exponent and raise it to another one, raise one power to another power, you're going to multiply those exponents. Okay, so 3 to the 4th raised to the 5th power, power to a power, multiply 3 to the 20th. 5 to the negative 2 to the power of 8, power to a power, multiply the exponents. X to the 7th raised to the 3rd, multiply the exponents. To raise a power to a power, what do? Multiply the exponents. Okay. All right, move this up a little bit. And the next thing we have is a rule for negative exponent. So when you have a negative exponent, you're going to put that underneath a 1. You're going to use a reciprocal. So this would be 1 over a to the n. Notice when you put it underneath the 1, then the exponent changes from negative to positive. So 10 to the negative 5th would be 1 over 10 to the 5th. 5 to the negative 1 would be 1 over 5. And x to the negative 7th be 1 over x to the 7th. The next negative exponent can be expressed as a reciprocal. If you happen to have a negative exponent in the bottom, say like 3 over x to the negative 3, then you would flip that to the top and make it 3x to the 3rd. If it's negative in the top, move it to the bottom. If it's negative in the bottom, move it to the top. Okay, this next one we've talked about a little bit, roots and powers. We talked about before, erase this one, that x to the 1/2 is the same thing as the square root of x. Okay, and we talked about the root number being on the bottom. So this a to the 1 over n would be the nth root of a. This is a root number, and it comes from the bottom of the fraction. So this one is 81 to the 3/2. The root number is 2, so that's square root of 81 raised to the 3rd power. 16 to the 1/4 would be the fourth root of 16 raised to the first power. And x to the 1/5 would be, or 2/5, that's 2/5. I can't read. Okay, it's 2/5 on the one it printed. It really looks like 1/5 on my paper. The root number is going to be 5, fifth root of x. And then this would be, that looks like a 1, so that would be a 1. If it's a 2, it would be a 2. A rational fraction exponent can be expressed as a root and power. The next one is more of the same. Let me clear these off. So the next is more of the same. So this would be nth root of a to the m. This one, square root of 81 raised to the third. And then you would keep going. Square root of 81 is 9. 9 to the third is, 9 times 9 is 81. 81 times 9, 729. Okay. The next one, 16 to the 3/4. The bottom number of that fraction becomes the root number. So 4th root of 16, which is 2. 2 to the third, which is 8. X to the 2/5. Fifth root of x squared. When you change a rational exponent or a fraction exponent to a root and a power, the bottom number, the denominator of the fraction is the root. The other one is the power. The numerator is the exponent. Denominator is the root. Okay. This last rule is equations. Okay, notice what we have here. We have the same basis. A is the base in both of those. And we have the equal sign in between. Now, if these two values, a to the n and a to the m, if those two values are equal and the bases are equal, what has to be true about the exponents? They have to be equal. If this whole thing, a to the n, is the same value as a to the m, we already know that a and a have to be the same. The only way those could be equal is if the exponents are equal. We use this property to solve equations. So let's take away those. Look at this one. 5 to the 2x minus 1 equals 5 to the 7th. I'm going to rewrite it right here. 5 to the 2x minus 1 equals 5 to the 7th. There's your equal sign. The bases are the same, so we're going to take these exponents and set them equal to each other. 2x minus 1 equals 7. Add the 1, divide by the 2, and now you've solved for x. You can solve for variables in exponential equations if both sides have a common base. Okay, we have one more that we didn't do right there. It's 9 to the x minus 3 equals 3 to the 4th. Okay, now we said if they have a common base, 9 to the x minus 3 and 3 to the 4th don't have a common base, do they? But I can rewrite this 9 as 3 squared. Now we have a common base. Common base is 3. What do I do with this power to a power? Multiply. So I have 2x minus 6 equals 4. Add the 6, divide by the 2, and there it is. So that's a quick review of your exponent rules. You have a page that has 2 columns. You're going to work the ones in column 1. Everyone in column 1 should have a matching answer in column 2. So really, you're going to work all of those. There, I'm going to attach, there's a coloring part. So you'd work number 1. When you find the matching answer number in the second column, it'll tell you what color. Since you're working from home and you may not have a printer, I'm not concerned with the coloring part. You can do that if you would like. What I would like to see is the work on the 2 columns. And you can do that. If you can print it, you can do that, or you can do it on your own paper. All right. Have a good day.